everybody, welcome to the pre-lesson video for lesson 13.4, which is going to be perimeters and areas of similar figures. And as I wrote up a bit in the Sway document, we've done everything that's involved with this lesson. We've kind of done. This lesson is going to be putting it together. So just one yellow box for this lesson, and basically that's the yellow box that's going to kind of put perimeter, area, similar figures, ratios, and proportions. Going to take it all and put it together. Okay, everything we've done is going to be put together in these three lines here. Okay, so let's take a look. If the scale factor of two similar figures is A over B. Okay, so remember what scale factor was. Okay, so if we have two similar figures, let's say two rectangles, and they're similar. Remember, similar meaning that they have congruent angles and proportional sides. Okay, so the proportion, the scale factor proportion would be, let's say if this side here is 2 and this corresponding side here is 6, our scale factor would be 2 over 6 or 6 over 2, as long as you stay consistent, which could reduce down to 1 over 3. Okay, so our scale factor here would be 1 over 3. So now, if the scale factor of two similar figures is A over B, then the ratio of their perimeters is also A over B. So what does that mean? Okay, it doesn't mean that the perimeters are the same. Okay, if our scale factor is 1/3 here, then the ratio of the perimeters is also going to be 1/3. But that doesn't mean the perimeter is 1 of the first object is 1 and the perimeter of the second object is 3. It means that the ratio of perimeters is 1 over 3. So in other words, if I know the perimeter of one of these boxes, so let's say I know that the perimeter of this box here is, let's say 6, 6, 12, let's say these are 2, 14, 16. So let's say the perimeter is 16 of this, okay? And I want to know what the perimeter is of that smaller object, okay? And all I know is one side length, but I do know that they're similar, and I know that they have this 1:3 relationship. So I could say if my ratio of perimeters is 1/3, same as the scale factor, what I can do is I can set that up in a proportion. Okay, let's say the perimeter is 16 here, so I could set that up, and I could say 16 here and X here. I want to know what the perimeter of the smaller box is. Okay, so I can set up a proportion just using the scale factor. Because remember, perimeter is length, okay? It's one-dimensional. This is a two-dimensional figure, but the length, the distance around, is just one dimension. It's just basically you could take this box and you could flatten it out into one length of 16 units for the perimeter, right? So we're just going to use that same scale factor because it's just length, one-dimensional length. So 1 times 16 equals 16, 3x equals 16. Divide by 3. Divide by 3, and this will come out not so nice, but that's the way it goes. So 16/3 or 5 and 1/3. So the perimeter here would be 5 1/3 units. Okay, so this is how these ratios work. Okay, so perimeter, length, same exact ratio. Okay, perimeter, scale factor, all the same because it's all one-dimensional length. But what happens when we get to area? Well, the ratio of the areas, let me get a different color here. Ratio of the areas, well, it's not going to be A over B because area, remember, are those 1-by-1 little boxes. They're two-dimensional. They have length and width. It's how much space takes up that figure. So we actually have to take, just like our units become squared, now our ratio of the areas has to be squared. So ratio of the areas is going to be A squared over B squared. So if it's 1/3 here, it's going to be 1 squared over 3 squared. Okay, so that equals 1 over 9. 1 squared is 1, 1 times 1 is 1, 3 times 3 is 9. So 1 over 9 is going to be the ratio of the areas. Again, that is not the actual area of each of those. The area of the big one's not 9. The area of the little one's not 1. Okay, it's the ratio of the areas. So now let's say I know that the area of this larger figure is, let's say, I don't know, no, I can use an actual 6, is going to be 12 units squared, 12 square units. I'll say inches squared. give this thing life. Inches. So again, now I know what one of the areas is, 12 square units for the area of the larger figure, so I can set it up in this 1 to 9 relationship. So 1 over 9 equals, so 12 down here, and x up here. And now I can find out what the area of the smaller figure is, because I know they're always going to have that 1 to 9 relationship. So 1 times 12 equals 12 equals 9x. Divide by 9, divide by 9, and we're going to get x equals 12 ninths reduces down to 4/3, or 3 1/4 if we want to use a mixed number, 3 1/3 if we want to use a mixed number there. So just like we did up here. So the area down here is 3 1/3 units. Okay, so let's go ahead and look at an example here, and hopefully this will start to come together. It's actually very straightforward. It's just getting an idea of understanding, when are we dealing with a ratio and when are we dealing with the actual areas and perimeters. So, all right, let's go. So let's first look at just establishing what the ratio of the perimeter and what the ratio of the areas are going to be here. So the rectangles below are similar. The ratio of the lengths of the corresponding sides is 6 to 8, which reduces down to 3/4. I kind of did that work for you here. So what is the ratio, smaller to larger, of the perimeters? Okay, and they didn't even have to say smaller or larger because you already know it's smaller or larger, because smaller rectangles in the numerator and the bigger rectangles in the denominator, right? So what is the ratio, smaller to larger, of the perimeters? So we know that the ratio of the scale factor is A over B, right? You've got this on our SWAY document there. And the perimeter, ratio of perimeters, I'm going to put that RP, is also A over B. And the ratio of areas is A squared over B squared. Okay, so what is the ratio of the perimeters? Well, we know that the scale factor is A over B, so this is your scale factor right here. So scale factor is equal to 3 over 4, so that is A over B. Remember, scale factor is your two corresponding sides, so it's the ratio of the lengths. And so what is the ratio of the perimeters? Remember, ratio of the perimeters is exactly the same thing as your scale factor, so that's going to be 3 over 4. Now what I want you to do is in the Google Doc, I want you to tell me what the ratio of the areas is. All right, and then we'll go over it in the next video. Good luck.